If it wasn't for AMD, we'd all be rocking Itanium CPUs by now. Itanium was from Intel, and this is the Itanium 2. It's the first version of the Itanium that mostly doesn't suck. And it is responsible, the microarchitecture is responsible for the death of the DEC Alpha and Spark and all these other sort of niche, but not really, microarchitectures. The world got a taste of the Itanium and said no thanks. AMD rescued us with the AMD 64. Those are pragmatic extensions to x86 that enable 64-bit functionality. They were adopted everywhere, including Intel. AMD's first in a lot of things. First to break the gigahertz barrier, first to break well, that's in CPUs and GPUs almost 20 years ago. First with the integrated memory controller, and now first with chiplets. The Athlon 64 and the Athlon 64 dual core, similarly, were watershed moments in the computing industry. They far outperformed anything that Intel had, and well, Intel, they threw a bit of a tantrum. They were fined $1 billion in the EU. I'm not gonna get into that here, but no matter how you wanna remember those events, the Athlon 64 was another watershed moment in computing. Threadripper, 3000, 3960X, and 3970X, they're another watershed moment for AMD and the computing industry as a whole. Two boards, the ROG Zenith Extreme and the MSI TRX 40 Creator, they're both rock solid and they have very similar features. The ROG, of course, is blinged out and over the top with its OLED status screen and DIMM.2 slots and the usual Asus accoutrement, while the TRX 40 Creator is clean and understated while being rock solid. It is, they both have 10 gig, they both have all the really high-end features, and both of my test systems use 64 gigs of Corsair Dominator DDR4 3600 memory configured the same way, and a 1 terabyte NVMe Corsair MP600. I did use multiple MP600s to get the testing done faster, but otherwise all the peripherals are the same graphics card, etc., etc. The testing went exceptionally well. The all-core boost was up to about 4.4 gigahertz, but that was a bit fleeting. Around 4 gigahertz is, I think, what you can typically expect in any scenario. These chiplets would seem to be even better bend than the 3900X and the 3950X. Every core is capable of 4.4 gigahertz, and the maximum is 4.5 gigahertz on up to 2 CPUs simultaneously. Very similar to the 3800X. The difference here is these chiplets seem to operate at higher clocks and lower voltages for the frequencies. What about Linux? Well, good news. On the Level 1 Linux channel, linked below, we've got a whole separate roundup on Level 1 Linux stuff, benchmarks, including the 3950X and the new 10-core, the 10980XE from Intel. So check that out if you want Linux stuff, but basically it's also bananas. Now in Linux testing, I did encounter some stuff that needs attention. Newer kernels will panic, which seemed to be a bug around just setting up the machine check exception devices in the files. Well, not really the file system, but you know what I mean. It doesn't seem like there's actually a bug there. It's just the names sort of overlap. It's kind of an odd bug. You can work around the bug by setting MCE equal off on your kernel boot parameter, but that's kind of an odd workaround, and I'm sure that I'll have a thread about that on the Level 1 forum and some workarounds and stuff like that. It's pretty easy to compile your kernel with a fix for that as well. So benchmarks, time index here for gaming, here for the Adobe suite, and here for productivity and science and workloads. You want games? Let's talk about games. At stock, the Threadripper just about matches the Intel 9900K, except for 1% lows, which are generally much better on Threadripper, owing to the Mount Everest-sized reserve computational resources that are available on a CPU. Windows could be running Skynet in the background, bent on killing all humans, and you'd never know when you're playing your game because there's that much computational horsepower available. Now what about the Adobe Creative Suite? Special thanks to Puget Systems because I recycled their benchmarks for this one, a little bit, sort of, kinda. The real-world performance on Level 1 projects is absolutely breathtaking. Far and away, the Adobe Suite is crazy there. I mean, we don't use the Adobe Suite for everything, but good lord, the Adobe Suite is fast. Also, After Effects, if you're into After Effects, especially if you use something like Render Garden, yeah, that's kind of nuts. We even tried to set up Render Garden to work on some real projects, some like real world projects to help with After Effects, rendering multiple frames at once, and good lord, they are fast. Although I'm sure that Puget Systems has done a more comprehensive Adobe Suite roundup, and you should check them out because we were seeing 3 to 5x speed up as not entirely unusual in our After Effects render times with something like Render Garden. First up in the science and pseudo-scientific section of the benchmarks in this evening's entertainment, or this morning's entertainment, wherever you happen to be. Geekbench 5. Geekbench 5 pretty much tracks the way that you'd expect. The real story here is that the single-thread performance is basically a parity across all of these CPUs. 3950X owes its single-thread speed to its 4.7 gigahertz boost, which is a little fleeting. 4.6, 4.65 is more what I was seeing in testing. And of course, the 9900KS CPU is pretty nuts when it comes to the single-thread benchmark. Indigo, well, that Indigo score is bananas. I mean, the 2990WX with a lot of massaging would get you to a little over 3. This is over 5. This is crazy. For 7-zip. 7-zip's got two modes, multi-thread and single-thread. And if you are not gimped by memory performance, the single-thread will basically scale on up and up and up and up and up. On the Threadripper 2990WX, there was a little bit of a story because 7-zip on Windows didn't do as well as 7-zip on Linux. And ultimately, that was because of Windows Scheduler, or the Windows Scheduler, and how it handles multiple processes. But here, we're taking a look at just single thread because it will scale pretty linearly. You just multiply by the number of cores that you have. What's interesting here is the 3950X is basically at parity with that top shelf 9900KS. Yeah, the Threadripper lags a little behind in these single thread aspect of 7-zip, but then you got to remember, you multiply that by 24 or 32 cores, and suddenly you are way ahead of literally everything else on the market. In previous generations, you know, the 2990 was a little slower, measurably slower per thread, but you had 32 cores to work with, and on Linux that scaled really well, not so much on Windows. Cinebench R20, it's a benchmark. The 9900KS, of course, is the fastest, but look at this score, 17,222. There was a lot of variability in this score with Cinebench owing to thermals and even the particular motherboard that was being used for testing. I think all the AIB partners are keen to push Threadripper just a little beyond AMD specs. I think about 17,000 is what you can expect from a 32-core Threadripper that is perfectly in spec from AMD, but if you just tweak a couple little things in the BIOS, you can easily score around 18,000. Yeah, 1,000 points higher. Isn't that nuts? Cinebench is pretty crazy. Single thread performance is basically at parity across all CPUs except the 9900KS, but that extra little bump in single thread doesn't really help you in just about any application that I was able to find. V-Ray, of course, V-Ray is another one that scales really well with lots of core counts, and so of course the Threadripper just demolishes. Here also, the 10980XE with its 18 cores is outperforming the 16-core 3950X. I don't think anything's super unexpected there. The upset is really that the 3950X with its 16 cores can do as well as it's doing against the 18-core current high-end desktop flagship from Intel. That is, of course, discounting the W3175, which is going to be another conversation. Overall, the CPU has a 280-watt TDP, but TDP can be a little misleading when you really get into it. We used a fluid repaired Intermax LickTech 2 and a custom loop and a Kraken X62. Now, AMD has told us that any 250-watt Threadripper cooling solution is going to work, and those coolers are 100% physically compatible with this socket revision. So anything that's designed for TR4, the previous X399 stuff, that'll physically fit. The move to a new chipset, it kind of makes sense to me. I mean, you get the new PCI Express by 8 downlink to the chipset. It's quadruple the bandwidth of competing platforms, and that gives you more connectivity opportunities for things like NVMe. We moved from 64 available PCI Express lanes up to 72. That's a win. You've also got ECC support if the motherboard vendors choose to support it, which will be in our motherboard reviews. And the motherboards support up to 256 gigabytes of memory, although your speed is going to drop down. I mean, officially 3200 is what the motherboards support, but as you increase ranks and density, that speed is going to come down. Let's talk about topology for a second. The reason that performance here is so good across the board is in part because the core-to-core latency has basically been normalized, and the CPU shows up to the entire system as a single uniform memory access node. There's no NUMA. Remember the bizarre performance of the 2990WX on Windows, but on Linux it was amazing? Yeah, that's not going to be a problem anymore. AMD did retain the option to group the cores into smaller groups. You can actually go into the UEFI and pick if you want 2 NUMA nodes or 4 NUMA nodes. The 4 NUMA nodes correspond to the 4 chiplets. That can help you with some edge case applications, but really only like servery people, super nerds, are going to care about that. For the Adobe suite, don't do that. The CCX to CCX latency is about 200 nanoseconds, tested with the Intel memory latency checker, and that was with DDR4 3600 with timings of 16, 16, 16, 36, 1T, which is what we use for everything here. AMD's got another trick up its sleeve with the whole CCX thing. Effectively, they're using either the topology or the cooperative cores thing to make the first thread basically get its own CCX. So the first CCX, the first thing to run on the system is going to have 16 megs of cache. That's kind of evolving a little bit. Early UEFI actually had a spot in the topology for this, so it was like thread 0 and then like thread 33 and so on. But I think they're going to accomplish the same thing with CPPC. The two fastest cores, the 4.5 gigahertz cores I mentioned before, they're always in CCD4. So that brings us to thermals and power. What's it going to cost in terms of thermals? Well, we saw temps as high as 72C during testing as reported with Hardware Info 64. I saw 81 once, but it turns out it was bad contact with the cooling system. Now, for the comparison to the Xeon systems and the 10980XE, the power utilization was far below with the Threadripper systems than the competing platforms. So I didn't attempt to do any overclocking yet. I will revisit that in a future video, but I'm not really expecting any single core faster performance. Maybe multi-core, maybe I can squeeze things out a little bit more with the multi-core, but I don't want to damage these CPUs. They're going to be in short supply. That just leaves the pricing. The TR3960X and the 3970X are priced at $1,400 and $2,000 US respectively. And how would you price a literal trendsetter in this space? Well, at first I was kind of alarmed. I mean, the 2950X was around $1,000 US at launch, and the prices have already, come down a fair bit, but $1,400 for 24 cores and $2,000 for 32 cores. AMD informs us that they will continue to produce the 2950X and other 2000 series Threadripper CPUs, and that those older CPUs will move down to fill the pricing gap between the $750 16-core 3950X, which is for the AM4 socket, and the $1,400 24-core Threadripper 3960X. I mean, from $750 to $1,400, that's quite a gap. Well, those older generation Threadrippers are going to fit in there now. So Micro Center here in the US already has the 2950X for around $600, and that's a really good deal. That CPU still performs great. It works really well. If you put it in UMA mode, all the creative stuff works great, and around $600 is a heck of a price. But Intel is the master of product segmentation, so we can move up the stack. I was looking at massively overclocking a 28-core W3175X and the more relatively pedestrian W3275X, with the W3275 being a Cascade Lake that was just released and has some hardware mitigations for Intel's security issues. Now, these are workstation Xeon CPUs, the best of the best from Intel, and priced at $3,000 and $4,500 respectively. Oh, and that W3175X, that's going to need a 1 horsepower chiller to run at 5 gigahertz like we saw at Computex in 2018. And it's also going to need thousands of dollars of motherboard and the rest of the cooling to max it out. Now, the W3275 is a little different story. It's a more normal Xeon, but I do happen to have an Asus ROG Extreme motherboard because there are a lot of those that died, the Dominus Extreme for the W3175 CPU, and we were able to include it in our testing because of that. Now, the W3275 is not overclockable. It's maximum 4.8 gigahertz, Turbo Boost 3.0, more realistically, you're going to see about 4 gigahertz on all cores. And it also costs more than the W3175, $4,500. So it's got less PCIe lanes and some other stuff. So suddenly, $2,000 for a 32-core CPU that outperforms a $4,500 CPU, maybe that pricing is not looking so bad. Now, the 3175 and the 3275 from Intel, they do have AVX 512. So if your software has been adapted to use AVX 512, then you can get the benefit from that. But these Threadripper CPUs have vastly improved AVX2, and more software uses AVX2 than AVX 512 currently. So still a better value in terms of real world performance with applications today, although that might change as more applications adopt AVX 512 because AVX 512 is legit bananas. If the market is willing to bear the price of a W3275, even at, $4,500, then the $2,000 Threadripper 3970X, it's a bargain. So in conclusion, I don't know what to say. I'm speechless. there is very nearly nothing negative that I can say. I mean, I wanted to complain about pricing, but the competing alternative is more than twice as expensive. So can you really complain about that? So AMD's got a little bit of work to do around the machine check bug and some other minor nits with the software, but the platform stability here was shockingly good. And for business customers that have deep pockets, you really only get one shot. So good job, AMD. And I'm really excited to see what Intel is going to produce for the future because, years ago, AMD's advances with x64 really kicked Intel's Israeli team into high gear, and they brought us a lot of the cool stuff that we're still enjoying today. So thankfully, no one is riding the Titanic, the good ship Titanic. So the prophecy is finally complete. AMD has restored balance to the force once again, and I'm really looking forward to what killer CPU Intel is going to cook up next in a generation or two. They're going to rise to the challenge from AMD, and that's going to be exciting. There's going to be fireworks, but 3990X for 64 cores? Wait, we don't 64 cores. Oh, it's not hard to infer that that's coming in early 2020 because 3960, 3970, 48 cores, I don't think that one's coming, but 3970, so there's an 80 and a 90, 3990, like the 2990, 64 cores, yeah, probably early 2020, but 48 core, probably not happening. I'm Wendell, this is level 1. This has been as succinct a review I could possibly do. We've probably got a lot more videos. All right, that's enough rambling. I'm out of here.